Right, natural logs. Okay, now this just means we're going to use the base of e, okay? And you can see that on your calculator, that's the ln button, okay? Remember the log button is log to base 10, the ln button is log to base e. Remember 2.71828, Euler's number. Okay, so, and remember things like, log to base 2. Log to base 2 of 8 equals 3, because 2 to the power 3 equals 8. So the base can be anything. But we only have two buttons on the calculator. Right, the natural log of 53. You put it in your calculator, you get 3.97. Okay, because e to the power 3.97 will give you 53. Remember that little pattern? Right, just try putting all these in your calculator. Okay, this is just for you to check. So remember, log to base n, sorry, log to base e, natural log of this will give you this. Have a look at that. But do remember this one? This is the one that gives you a negative answer. Okay, so the natural log of 0.00, whatever it is, apparently is negative 10.64. Try it in your calculator. Okay, so the log of 0.00, fractions, like a half or a third, will give you negative answers. But you cannot log a negative. Remember that? You can't log a negative. So just same, you can't natural log negative 5, because e to the power what will give you negative 5? There isn't anything, okay? Because remember, even if x is negative, that'll give you a fraction, not a negative answer, okay? How about this? Well, the natural log of e. Well, remember the natural log you can think of as log to base e, okay? So log to base e of e, well, anything to the power 1 will give you itself, okay? Now remember that. Remember when we had this one before? Log to base 8 of 8. That equaled 1. Because it's like saying these two are the same. Because these two are the same, the answer to this is 1. Okay? The answer to this one is 0. Because remember, anything to the power 0 equals 1. Doesn't matter what the base is. The log of 1 is always 0. And again, if you remember from log graphs, okay? Log graphs always go through right here 1, 0. Because when I log a 1, I get a 0. That's always on the graph, as long as it hasn't been moved. Okay, so let's have a look at the log x graph. And again, it just looks like any other log graph. Here we go. Okay, it's just got a different base, so there'll be slight variations. Again, remember, here we go. So here's log to base 5 of x, because apparently this is 5 to the power x. Okay, here's the exponential. Here's the log. That's using base 5, just a reflection across the, remember the y equals x line? I can draw that nicely. Oops, horrible. Right, so that's the natural log of x graph. Okay, let's try some transformations. Remember what this means? Log of x plus 3. That's the left, that's not up 3, that will be just log of x, then plus 3 tagged on at the end, or 3 plus natural log of x, okay? This is log of x plus 3. This is 3 to the left, okay? Let's have a look at it. And there it is. So remember, normally it would go through here, and it wouldn't, I mean, again, remember this, the y-axis would be a vertical asymptote, okay? Remember domains of log graphs? If you look at them, if you look at the domain of a log graph, okay, it's always 0 to infinity, all right? But this has been moved 3 to the left, so it's been moved from this x-intercept, 1, 2, 3, to this x-intercept. So this, x equals negative 3, will be the vertical asymptote. I've just moved it 3 to the left, okay? If that helps you draw it. All right, just do it a little asymptote. Instead of the y-axis, I've moved it 3 to the left. Okay, so let's have a look at another one. This one here, right, a half. That means it's been vertically shrunk. That's kind of hard to draw unless you plot a lot of points accurately. But look, negative in front. That means x-axis reflection. The 3 at the start, a positive 3, means it goes up 3. Let's have a look. Okay, where is it? There it is. So again, remember, if this was the original, not a bit hard for me to draw, okay? Then, if it's been flipped through the x-axis, okay, instead of going down here, now it goes up, so can see what it looks like that, all of a sudden. Vertically shrinking, hard to draw, the half, but look, up 3, up 3. So again, x-axis reflection, up 3, so instead of crossing at 1, 0, 1, 2, 3. There's the new point. It's been moved up 3. Okay?